A topic that is becoming very important now as deployments grow from pilots to reliable production. One thing is non-negotiable at this point. This is security and privacy, especially when devices are tiny, inexpensive, and power constrained. I'm Senior Director at Infineon Technologies. I'm responsible for our program on ecosystem and partnerships building. I operate at the intersection of standards, where technology regulations operate. And I'm myself chair of NFC Forum, which is an RFID technology. I'm a board member at FIDO Alliance, which is developing authentication standards for ID and logical access. And I'm also director at Eurosmart's IoT committee, where we are looking at policy advocacy and providing expertise to the EU Commission as we navigate the EU Cyber Resilience Act and EU DI wallets. With all of that and more than 20 years of experience in security and privacy, I'm going to talk about what is security and privacy for Ambient IoT. We have spent years talking about Internet of Things, and Steve started his talk with that. In 2026, we have entered the era of Ambient IoT. There are billions of sensors that are essentially invisible, batteryless, low cost, and woven into every product that we touch. So today we are going to discuss the hidden security costs of this invisibility and how to scale trust when hardware costs are less than a dime. The roadmap of my talk is going to be a little theoretical at this point, but rooted in practice. So today I'll start with high-stakes story in pharma and home care that Steve already introduced to ground our threat model. And then I will move to specific security and privacy risks that an ambient IoT tag would be exposed to, the villains of our story. Before driving into the technical examples or solutions, our so-called heroes, the hardware and the protocol level security solutions that would make security not only economical but viable at scale. So ambient IoT for pharma, we aren't just tracking pallets anymore, we are tracking at the level of vials, individual vials. And this ambient IoT tag could report temperature excursions or signature mismatches. We can then prevent a spoiled product from reaching a patient. In this context, security is not about data protection, it's about protection of the patient. Think of smart pill organizers that assist elderly by alerting their phones when a dose is missing. It provides autonomy for the patient and some relaxation or some convenience for peace of mind for the family. But this convenience can create an intimate attack surface that, which can be tracked, can be attacked. If an unauthorized party can fingerprint behaviors, then they can harm you. So here you must protect data to protect a person's privacy. The threat model is twofold. Security risks include counterfeiting and threat targeting the asset, while privacy risks include stalking and unauthorized tracking targeting the individual. So in the ambient IoT world, these aren't just cyber problems. These become physical world problems. If a high-value asset can be tracked, it can be stolen. If a person can be tracked, they can be harmed. So the defensive approaches that I would like to propose here is our defense in depth. So we have to keep building security on top of security. Making the silicon itself tamper resistant at the physical layer is where you begin with. And then you build on top of that. And then adding unique identity with cryptographic proof that makes cloning difficult and revocation easier. Then we move to the protocol security. Using communication, like communications with authentication and integrity protection that enable replay prevention is what you build on top of it. Finally, we will have on top of this pillar where we have physical security and protocol security, we build regulatory guidelines, regulatory rules, and regulatory security. So with GDPR and HIPAA, which provide legal frameworks to build security on top of what is provided by the technology. So these defensive approaches that I'm talking to you is an example of how ambient IoT systems can be built on top of what is already available. Here is a reality check for 2026, the 10-cent security problem. In the embedded world, we are used to constraints, and ambient IoT is taking us to the next level. We need high-grade crypto on a device where the entire bill of material is a few pennies and the power budget is a few microwatts. If our security protocols uses too much microwatts or is too expensive, guess what? It's not going to get implemented. So our goal in the Ambient IoT Alliance and in the Ambient IoT ecosystem is to build security economically viable. It has to be almost free in terms of power and negligible in terms of cost. The answer lies in the silicon to enable cybersecurity and cyber deterrence. For cybersecurity, the solution is in the silicon by moving from software-defined security to hardware acceleration and symmetric cryptography. We achieve an asymmetric advantage. This asymmetric advantage is the only way to build security in billions of devices without breaking the banks or the battery. For cyber deterrence, we increase the pain for the hackers. We increase the attacker's cost by orders of magnitude while only increasing the defender's cost by a fraction of a cent. This is where the battle is. This is where the security for ambient IoT really shines. So I would wrap up here with a few thoughts. The way I see it, the threat to ambient IoT aren't necessarily new, but their scale indeed is. We need to leverage proven technology and we need to reinvent crypto. We need to optimize it. We need to design for scale, and standardization is where this becomes essential. And the Ambient IoT Alliance is doing precisely that. These are essential to minimize costs and to maximize interoperability. We need global standards. And last but not least, we need to deliver value. Trust is the product. Without security, ambient IoT is just a liability. In my view, therefore, security is a business enabler and not a cost center. Let's build an invisible world that we can actually trust.